Hi everyone. So my name is Omer Sagi and I'm a data scientist at Dell. Also, as Lior mentioned, I'm a PhD candidate in this department under the supervision of Lior. My team in Dell is located here in Be'er Sheva, right across the bridge. We develop solutions internally for Dell based on machine learning and data science approaches. So we improve both internal business processes as well as Dell's product. Another thing that we do is taking what we developed internally in the Dell organization and implement it within our customers' environment. So today I'm going to talk about a work that I led in the previous 2 years, which was around improving DevOps and QA efficiency using machine learning and NLP methods. Now, more specifically, we developed a recommender system. Can you hear me? It's okay? We developed a recommender system that, given a bug or a software issue, recommends for 5 historical issues that are very likely to be duplicate of this new bug. So the investigation time may reduce from several hours and even days to several minutes. Before I start, it is also important to me to mention Nimrod Milo and Maor Sadeh. Nimrod has initiated this project and led it until he moved to other challenges. And Maor also took a very important part in this development and implemented it within Extreme.io develop teams. Extreme.io is a storage solution provided by Dell. Okay, so I will start with presenting the business problem and then the inspiration for our solution. I will continue and present the solution and then the results that we got and the feedback from the customer. So the business domain that we faced is investigating failed tests in QA and DevOps teams. So our users are QA engineers. And this figure illustrates the business process that we're facing. So let's take, for example, that we have a QA engineer named Ben. And Ben's daily work is to design tests that aim to improve the product. Now, what is a test? A test is something that checks whether the product does what we expect it to do. And the one possible option of a running test could be that the test will raise some exception or some error. And in this case, we call it a failed test or an issue. And whenever there is some failed test, Ben is required to investigate what happened, to provide root cause analysis, so the product folks and the R&D department can improve the quality of the product. Now, those tests can be stress tests, there can be some logical tests, any combination and every scenario that crosses Ben's mind. So how does Ben investigate what happens in the test? He needs to read the story or the relevant pieces in the story of what happened in the test. And this story is represented or given by a log file, okay? A log file is a huge file that contains sometimes millions of log messages. Each of them document some event that happened. Now, it's a very tedious task to go over those log files. The error is appeared only in few messages, and the root cause may appear in other messages that are thousands of messages before the error message. So most of QA teams uses some tracking systems like Jira, Bugzilla, Slack, or other tools that enable them to investigate those tests more efficiently. So one thing that Ben can do when facing a failed test is to open a Jira ticket, okay? And the Jira ticket, I mean, in the beginning, you can title it with what happened, according to what happened in the error and some initial assumption about the failure itself. And then you can also link it to other team members. So for example, Richard can comment on this ticket and tell Ben, hey, I had the same error, and I found those 3 messages to be very informative. And using this information, Ben can look at the original or the new issue and decide whether it's actually related. And in some cases, Ben may find Richard's comments very informative and even mark his case as duplicate of Richard's case. So let's say that Richard's issue is 26025, so it is marked as duplicate. And if it is marked as duplicate, it basically means that Ben resolved the issue. Okay, now duplicates are a significant portion of the test, of the failed test. Okay, it's about 20 or 30% of the overall tests sometimes. So something that we want to do is automate this process. I mean, instead of linking and having all this communication, just having something that automatically recommends for duplicates. Now, it is pretty challenging. I mean, basically, in the current phase, investigators may overlook some duplicates while treating other duplicates mistakenly as actually duplicates. What we want to do is to find some solution that take what is actually the content of the log message. So in this case, Ben facing some log file that contains the messages A, B, and A, and it thinks that it is a network outage. So we want to recommend Ben for the case that include those messages, which is the lower left one. Okay, and Ben is of course biased by his semantic thoughts about or semantic, let's say, perspective about what happened in the issue. So he may find or may search for a network outage and see that there was indeed some issue titled network outage, but its DNA, the log content, was different from the actual duplicate. Okay? So our solution, what it does is automate this process. I will show you the end result, which is, just a second. The end result is a search system in which Ben can enter the file path of the log file, click on the search button, get 5 results that are most likely to be duplicates of the original case, click on the JIRA ticket of those issues, and see or judge by himself whether or not it's a duplicate. So it's not fully automated, but it's something that really fastens the whole process and save a lot of time. Okay, now the main part of this talk, this brings us to the main part, which is what is the engine that works behind this recommender system. So we took some known concepts, known and simple concepts from NLP, more specifically document similarity. Now what we did is pretty analogous to document search systems, textual document search systems. In these systems, the method is, in most times, user provides some input document. We can call it a query document. It can be a query test or a text, sorry, or I don't know, document, actual document that we want to find 5 other similar objects to. And then this query document go over a text processing module, okay? The text processing module can include tokenization, stop words removal, and stemming, and any other text processing procedure. And after we conduct this text processing, we left with a vector, okay, with a vector representation of the text. And when you have a vector representation, you can apply similarity measures like Euclidean, cosine similarity, Jacquard distance, and there are many other similarity measures. And afterwards, we can rank the objects or the documents that are most similar to this query document and show those to the user. Okay, now let's talk about the similarity measures. The most common similarity measure in this case, I think, is cosine similarity. Cosine similarity virtually is the angle between the two documents, the vectors that represent the two documents. Let's see it in this example. Let's say that we have three documents. One of them is New York Times, the second is New York Post, and the third is Los Angeles Times. I mean, regardless of bigrams here, let's say that we test only the words. So it is apparent to us that New York Times is very similar to New York Post, while New York Post has nothing to do with Los Angeles Times instead of textual similarity. Now, converting or transforming those textual representations to the vector representation, we can actually quantify this similarity. So the cosine similarity, for example, between New York Times and New York Post is 0.66, while between New York Post to Los Angeles Times, there is no similarity at all. Okay, now having all that in mind, we wanted to use this same approach on log file search system. Now, it's not that trivial because presenting a log file as a vector is not like representing a textual document in a vector, because we have some words that are very rare, but not very informative, like memory addresses or like file names or usernames, okay? And it's not something that represent what happened in the incidents very well for us. Okay, on the other hand, it is machine-generated text, so we may have some words that are very common because they were generated by a machine, and we may think that they are not that important because this is what we do. We can call it stop words in case of text, but actually, when dealing with logs, they are very informative words. So we need to find another way to represent the log files, okay? Now, having that in mind, the rest of the architecture remains the same, okay, if we want to develop a system like the one that I presented. We have the vector representation, the similarity measure. The only thing that is different is how we process the logs. So this was our main challenge in this first stage. And the idea is that, I mean, what we chose to do after consulting with domain experts in Dell, so they told us that like words are the building blocks of textual documents, log messages are the building blocks of log files. So we need to find a way to extract or to find the stem form of a log message and then use it as a vector dimension. So what we chose to do is taking some property of the log message called event ID and concatenate it to the log level. Log level can be info, critical, error, etc. So in this example, we can see a very simple log file with only 5 messages. And we can see that, for example, event ID 14 with concatenation to info appears 2 times, okay? One time, in the first time, system I writes to system B, and in the second time, system C writes to system D. And although the content is different, we still count this event as appeared twice, because what we want to do is how many writes or how many times the event ID has occurred, okay? So we found it to be a very good representation of the log file. Now, evaluating this, evaluating our approach, so of course we conducted an experiment excluding some queries that, some issues that we didn't see, and try to test it. The one measure that is relevant here is the top 5 precision, okay? The users told us that they don't want to see more than 5 results. So for us, it was the upper bound for how many results we can present. Of course, as we present more results, then there is more probability that we will present a right duplicate or suggest for a right duplicate. But we focused on the top 5 precision. And the result here on average was that in 63% 93% of the queries, one of the results in the top 5 was actually a duplicate and was actually relevant. Okay, at least one of them. So it was a fair result, but not enough for us. So we wanted to test another approach. I mean, moving to a supervised model. In this supervised model, it's someone familiar with face recognition. It has some parallels. We can take 2 issues, create some pair vector. We don't use deep learning here, just feature engineering similarities between the 2 issues. And then take this pair vector that represents the relation between those 2 issues, feed it into machine learning model that tells us whether those issues are duplicate or not. Now, 2 questions that probably raised from this illustration is, the first one is how we can create this pair vector, and the second one, from where do we get the labels for the duplication. So I will try answering the first question. Here we have an example of 2 issues, issue 1 and 2, and we can, instead of looking at the similarity of all the event IDs, we can choose different similarity dimensions. So one similarity dimension can be how similar are those issues in terms of info messages. And in this case, we can see that the red marked messages are the relevant, so this is the value of the info similarity. Now we can do the same for critical messages. Now we can see in yellow messages that the log level in which is critical. And in this case, the critical similarity is 0. Another thing is we can use actual properties that's inside the content of the text, using other parsers and not reading the event IDs. So in this case, we count messages that have the word panic and the serial number of the panic after this word. But more interestingly, we can also collect some static properties, configuration properties, and see how similar are those issues. For example, are they running on the same operation system? What is the hardware distribution in each of these, in the hardware that runs each of these issues? What is the time difference in days? So for example, this one was run 12 days after the issue 2. And of course, this vector is much larger. It contains dozens of dimensions, and in the end, we're supposed to map each of these vectors to whether this relation is duplicate or not. What leads us to the second question: how do we know that this vector is of duplication or not? So, as I presented in the beginning of this talk, we had the data from JIRA, or other tracking system. So we took all the historical assignments of issues to the duplicated issues, and used that as positive examples or positive instances in our machine learning model. And we also generated issues pairs that are not duplicated. And this can be a subject to another talk, how we can generate those, let's say, non-related pairs. And the machine learning model that we used was distinguished between the duplicated and the non-related issues. Okay, now it dramatically improved the results. So again, looking only at the top 5 precision, the top 5 precision has increased from 63% to almost 80%. And again, it means that from all the queries that we ran, 80% contain at least one relevant result in the top 5. So we said, yeah, okay, that's good enough for moving to production, and we moved to production during the launching of a new version in Extreme.io, and got some very rave feedbacks about it, that it dramatically helped to decrease the investigation time, and QA engineers could put more effort in designing smarter tests rather than the tedious task of investigating those tests. That's it, I think. One more thing, our team right now is hiring, so feel free to approach after this talk. And any questions, you're more than welcome to ask. Thank you.